Last lesson in trigonometry, we are going to graph cosine and sine functions. We're not going to actually graph them, we're just going to recognize the graphs of them. But first, let's just go quickly through our radians. So where do we start? Bow ties, pi over 6. Pi over 6. This is pi, or 6 pi over 6. Therefore, this is 5 pi over 6, and this is 7 pi over 6, which makes this 11 pi over 6. Are we feeling better about those? Fantastic. Let's go ahead and do our butterflies now. Butterflies are pi over 3s. 1 pi over 3, 2 pi over 3, messed that one up, 2 pi over 3, I'm going to skip my 3 over 3, 4 over 3, and 5 over 3. And finally my fourths. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and 7/4. Notice that they are all odd numbers. Okay? Moving on. Degrees. What's the pattern we saw in degrees? They end first at 45, then in 45. As we gain a hundredths place, we lose a tens place. Gain a hundredths place, lose a tens place. Gain a hundredths place, lose a tens place. And then the remainder of the circle was just counting by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33. Add a 0 onto each one. I almost did it perfect. All right, we're good? Oh, 360, thank you. Okay. And like I said, our unit circle, these are the coordinates of our circle. And we found that it was interesting that this circle this triangle right here is the same as this triangle right here, only flip-flop. So my x and my y switch places, just like there's my x on this one, which is root 3 over 2. That changes, and now it's over here, root 3 over 2. And same thing with the y's, they switch. So we'll talk a little bit about that right now. Okay, so this is something that you're going to see on your test. Or sure, there's a question like this. Okay, this is the first thing we started with in the unit. We talked about that vocabulary and coterminal. What does it mean to be coterminal? Yeah. What's terminal mean? To end. So that means they have a co-ending. They both end together. Okay, so let's go through this vocabulary. Name a positive angle. So my ending angle is going to be positive. That is coterminal with negative 5 pi over 3. Hold on. So negative 5 pi over 3 technical difficulties, sorry. All right. So this is what I want you to do going into these quizzes and tests. Don't just stare at it and go, oh, I don't know. I don't get it. I don't remember this. What should you do? No. Thank you, Melody. I appreciate that. You could draw your butterflies and bow ties. You could say, hey, I may not know what coterminal is or positive angle, but I think I can figure out where 5 pi over 3 is, right? You could double it. If you don't like 5 pi over 3, you could say, hey, I'd much rather work with 6's And I also know that negative means I'm going in the negative direction or the opposite direction. So I'll work with sixes. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6. There is negative 5 pi over 3. 10 sixes. I'm going to erase the rest of this. I'm going to draw myself a directional arrow. That way Mrs. Mahler knows that I went in the negative direction, and I know I did. So I started here and I went here. Okay, so what's the question asking me again? Name a positive angle that is coterminal with this angle. Coterminal means ends. So positive angle means I go in this direction and I'm going to end right there. So that is a pi over 6. Sorry, pi over 3 angle, right? It's the same thing as my reference angle. That's a positive angle that's coterminal with my other angle. What would the angle be in degrees? 60 degrees. I've got that right over here. Right? Where is it? Right here. Reference angle. 60 degrees, pi over 3. Good. Okay. Next one. Can you do this one? Name a negative angle that's coterminal with 210. Well, where's 210? Which quadrant? Show me with your fingers. Which quadrant is 210 in? Okay, most of us have got it. It's in the third quadrant. So 3, 6, 9, 12, 15, 18, 21, 210. It's right there. That's 210 degrees. So what's a negative angle? How far do I have to go around? Well, 30, 30, 60, 90, 12, 15? You could subtract. So it's negative 150 degrees. Percent is not correct. It's 6 period. Okay, what is that in radians? Well, if that confuses you, figuring out what that is in radians, then think about it in terms of if it was, I would just go like this. Okay, 150. 150 is normally here. So what is that in radians here? It's 5 pi over 6. So it's negative 5 pi over 6. So there's 3 pieces to that question. Can you draw the angle? Can you tell me what's coterminal to it? And then can you turn it into radians, or if it's in radians, can you turn it into degrees? Okay? All right. If we have time, we'll go back and practice that more. All right. This one is on the final and on the test. This one is important. We didn't do anything exactly like this, which is, it doesn't need to be. We didn't have to do something exactly like it. If you understand, this is one of those questions, if you understand the concept, you'll understand the question. Okay, so this one's a little bit of a stretch. That's why I'm going to show it to you now, and I'm going to show it to you again and again, okay? So, what is the exact value of sine pi over 3? Where do I start? Pi over 3. So let's find pi over 3 first. Pi over 3 is a 60-degree angle. Where do I go from here? Down to the x-axis. Why? Because I got to make a triangle, right? So I can evaluate sine. So I'm going to make a triangle. So this side is my 1, this side is my 2, and this side is my root 3. Sine, Mrs. Mahler taught you, cosine is your x and sine is your y. You don't have to remember that because you also have the so. Sine is so, which is opposite over hypotenuse. So opposite of this angle is pi over 3, and hypotenuse is 2. So my answer to this question is root 3 over 2. Second question. So that you should know. You should be able to do that fine. This is the part here that stretches you a little bit. What angle would cosine have to be to have the same value? Exactly. That brings us back to this. Right? So if root 3 over 2 is here, right? Root 3 over 2 here is for cosine, or my y, then isn't cosine going to be here? Do you see why I showed you this now? It kind of explains why that works. Because the triangles are the same, they're just turned differently. So the x's and the y's, or the cosines and the sines, they just change places. So, and this is a way that I could kind of test myself on that one. I could say to myself, okay, first of all, I know for sure, so I want to know cosine of what angle makes root 3 over 2. Well, I know for sure it's not pi over 4. Why would I know for sure it's not pi over 4? Because a 45-degree angle has a 1 and a root 2. Right? We don't even have a 1 or a root 2 involved in this right here. So I ask myself, well, I know it's not pi over 3 because that's the sign. So let's try pi over 6. Does pi over 6 work? Let's draw that triangle. Pi over 6 is here. This is 1, 2, root 3. Cosine is my x value. Right? So that's my root 3. And then my hypotenuse is 2. So that works. So the angle that cosine has to be the same value as pi over 6. Okay, we'll come back to that. Like I said, maybe we'll do this one tomorrow before we start. All right, last lesson right here. Okay, I'm going to go quickly through this part. Okay, I'm going to show you the parent graph of sine. I've shown it to you. This will be my 3rd time showing it to you, maybe even my 4th time showing it to you. Sine always starts at 0. Why? Because y starts at 0, and cosine is y. And sine is y. Oops, 0, 1. It's 1, 0. This is my y, or my sine. So it always starts at 0. And then it has the waves to it. Correct? You guys have seen this before. This is the parent graph of a sine function. What do we normally do with parent graphs? What do we do? What type of transformations do we happen with them? Translations? Yep. What translations, which part of the graph? I should say it like this. If I had x squared, what could I do to x squared? What are some transformations? I could add 2. What would that do to it? It would make it shift up and down. That would make it translate, right? Up and down. What else could I do to it? Add a negative? That would make it go down. What else could I do to it? Square root it? I heard? Did I hear square root? Square root would give me inverse. But I'm just talking about just adjusting it. Dilate it. I could put a stretch on it. That's with exponential. But I can do something with the x, right? I could do this, and that would also translate it. We're not going to work with this today, but we are going to work with stretching, maybe going in the opposite direction, and shifting up and down with a cosine and a sine graph. Caitlin, I need you to wake up. This is such an important lesson. All the way up. Sit up. Okay, so here's my cosine graph. Cosine always starts at 1, and it looks like this. So it starts at 1 and ends at 1. Did we mention before that sine looks like an S? That also helps you remember. Okay, so let's get started. So what's happening to this? First thing I'm going to ask, I'm going to ask myself 4 different things. Cosine or sine? This one tells me. Number 2, is it positive? Does it have a stretch? This one's going to be the only new one to you. Is it a, I'll just say period. I want to know about the period. And finally, does it shift? Does the midline shift? Those are the things we're going to ask ourselves. So first of all, this one is a sine function because it looks like an S and it starts at 0, right here. This 2 right here, do you guys see how it stretches? Instead of going up to 1 and going down to 1, it stretches to 2. That's what that 2 does there. Okay? Next one. There's a cosine. This cosine starts at 3. And it goes down to -3. That's why it's got a 3. It's stretching by 3. Okay, so far? We're stretching. All right, so amplitude, distance from the midline. So that's our stretch. A is our stretch. Now we're going to talk about B. B is the period. Okay, so here is one complete cycle. One complete cycle, if this is 2 pi, this is 1 rotation in 2 pi. This one is 1 rotation in 2 pi as well, but it's just a cosine function. 1 rotation in 2 pi. We can look at it from a equation status, or we can look at it just from looking at the graph, and I'm going to explain that right now. So we're going to talk about 1 full period. Okay, so if this is 2 pi, would you guys agree I have 1 full rotation in 2 pi? Yes. Do I have 1 full rotation in 2 pi here? Yes. I don't, right? I only have half of a rotation in 2 pi. I have half of a rotation in 2 pi. There's another way to look at it. I could also say I have 1 rotation in 4 pi. Would you agree? If I went halfway around and that's 2 pi, then the other half just must be 4 pi? So then how am I going to make this right here 2 pi? Yeah, I could divide both sides by 2. And isn't that what I have over here? 1/2 of the rotation equals 2 pi? This is always what we want. We want to know how many rotations in 2 pi. All right, over here is a cosine curve, and I only have half of it in 2 pi. I have all of it in 4 pi. Melody? All right. Lastly, the midline. So my midline is my curve. My curve's just going to shift up and down on the y-axis. Right, Matthew? All the way up. Sit all the way up. I know this is exciting stuff, right? We're almost done, okay? I've got 15 minutes, about 15 minutes. I'm going to talk about 5 more, and then you guys are going to practice this. All right, so remember I said there's 5 different things I'm going to ask myself. Up here, I've got 1. Let's do it with color. Actually, I've got, for my first one, is it sine or cosine? Sine, because it's an S. It also starts at 0, so it's sine. This is going to be a trig function. So I have sine. Is it positive? It's growing right from the beginning, right? So it's positive, so that's good. Does it have a stretch? It does. It has a stretch. It's not going up to 1, it's going up to 1.5. Does it have a shift? No shift, right? There is no shift. I'm going to put +0 on this one, but you normally don't have to put +0. Now I just have to talk to myself about the period. So I'm going to start from 0. I can go half in pi, right? I can go half of a rotation in 1 pi. Do we want 1 pi? We want 2 pi. So what am I going to do? Multiply that side by 2 and that side by 2, and I get 1 full rotation into pi. That's how to do it with an equation. I have 1 full rotation. I don't need the 1. I have 1 full rotation in 2 pi. Or I could have just looked at it like this. Okay, if this is half in 1 pi, couldn't I just keep going to get to 2 pi? And I would have said to myself, I've got 1 full rotation in 2 pi. Let's do another one. We're going to do that right now. Cosine or sine? This one's cosine. Is it positive? No, it starts down here in the negative, right? So it's negative, and it has a negative stretch. It's got -2. Does it have a shift up and down? Midline stays at 0, right? And so now I just have to think about the period. All right, so here's 1 period. I get 1 period in pi. I don't want pi, I want 2 pi, so I'm going to get a whole nother rotation. I'm going to get 2 full rotations in 2 pi. You can just draw it and count them, right? Or you can say, okay, if I got 1 full rotation in pi, then I better multiply that by 2, and that gives me 2 full rotations in 2 pi. We're always talking in terms of 2 pi. Couple more? No. I don't think so. Okay, what about this one? Cosine or sine? Sine. Is it positive or negative? Does it have a stretch? Right, it's got a stretch of -2. Is it shifting up or down? Nope. And what about the period? Here's a full rotation. 1 rotation in 2 pi, so it's just, there's nothing in front of the theta. This is angle, right? Rotation. Matthew. About this one. This one's a little different, right? This one has got my midline shifted, but we do know it's sine. You're right. So h of theta equals sine. Is it a positive? It's going positive. Is it stretched? Nope, because to go from 2 to 3 is only 1, so there's no stretch on it. We know that there's a shift. What's the shift? And now let's talk about the period. Let's see. 1 full rotation in pi. 1 rotation in pi. Therefore, you're going to have 2 rotations in 2 pi. I think I have 1 or 2 more. All right. Sine or cosine? Sine. Is it positive? Yes, it's growing. Is there a stretch? Stretch of 2? Nope, there is no stretch. It looks like a stretch for some reason, right? So there's no stretch. Is there a shift? Our midline shifted up 1. And what about our period? I've got 1 full rotation in 4 pi. 1 rotation in 4 pi means I have half a rotation in 2 pi, which if this doesn't make sense to you, you can just look at it, right? I can see that at 2 pi is right here. There's only half of a rotation. I've only gone halfway around. So this is going to be 1/2 theta. How are we doing? Pretty good? You guys ready to do your worksheet?
Yeah.
Let's see. That's the hardest one on your worksheet. It's number 4. Try that one first. You don't have to, but we'll look at this one in a few minutes, okay? It's day 6. Okay, so here's number 4. Thank you. All right, so I know that it's a cosine. What I was saying to ladies is it looks like it has a C. It looks like a C, right? Or no, it was Dylan. So it's cosine. It's stretched by 2, but it's positive. There's 1 complete cycle, 1 cycle in 2/3 pi. How do I make it 2 pi? Multiply both sides by 3. So there's 3 cycles in 2 pi. That's it. Bye. That's your hardest one on there. Have a great day, guys.